All right, recording is on. So let me give the little speech. Students who participate in this class labs. As you're doing this, you can write like lab number 1 here, etc. I'm going to do a little lab tutorial. So this isn't going to be necessarily exactly correlating to lab 1. I'm going to go over like doing addition, subtraction, multiplication, division, all that good stuff. And then towards the end of the lesson, we'll get more towards what you guys are actually doing in the lab, which will be more so defining the functions and then plotting them. So yeah, so I'm going to call this lab tutorial. Right. And now I'm going to start using these things up here. I like using these to organize my information. So again, they're not really necessary, but they're pretty cool to organize my information. So up here, I can write something like question 1. And if I was to write here like 5 plus 5, whoever's reading this is going to know that question 1 was this. And if I press enter, you'll see that it gives me a result. So when I write my math inside of one of these shapes, you'll see that this thing turned into math. And then I can write whatever the mathematical expression is that I want to do here. Press enter, and it'll go ahead and give me the result here in blue. Anybody not understanding so far? Just want to get a pulse of the room.
Hey, Professor, quick question. How did you get the name up there?
Yeah, so I just changed this thing to text. So from math, I swapped it over to text, and then I just wrote my name.
Okay.
And I recommend using this text feature anytime a question asks you to, sometimes a question will ask you something, right? Like it may say, solve for this, and then explain what happens when this thing is going like this. So if you need to explain, you can always write it in text, right? You don't want to write stuff at math. Of course, if a question asks you what is 5 plus 5, you can just write this and give this as an answer, and people will be like, okay. But if it says explain, maybe you want to explain here, right? Like 5 plus 5 is 10 because, etc. Right? All right, so moving on, I'm going to go into subtraction. So let's say we were doing something like 10 minus 5. 10 minus 5. Yeah, this minus we can find right above our P, also right above the plus sign in our number pad. So that's our subtraction. Next we have multiplication. To do multiplication, we're going to use Shift 8, which gives us the little star. So let's say we were doing 10 times 3, we would write 10, then Shift 8, and 3. That gives me 10 times 3 here. You can also use the star symbol in the number pad, which is next to the minus sign. And now lastly, for the basic operations, we have division, which is also going to be how we create fractions. So let's say we were doing 10 divided by 3. We would write it just like this. 10 divided by 3. And this division symbol is the, the forward slash that's connected to the question mark. So it's the forward slash. It's also the number right next to your number lock in your number pad. If you want to use that one instead. So quick note that this is also the way we want to create fractions. So the way we can write the division symbol, it's going to be the way we create fractions as well.
Hey, Byron, is there a way we could do these labs without using Maple? Or like, I mean, I'm having problems downloading it and it's just kind of, confusing. So like, is there a way we could do it without using this specific software? It's like, I don't know, getting a copy of the problems and doing it some way else.
No, you have to use Maple.
Oh.
All right, so moving on. Let's say we're doing an exponent. Actually, you know what? Next, I'm going to show you all how to make this. Let's say we had 10 over 3 here, but we don't want it to be 10 over 3. We want it to actually give us a decimal answer. Right? We actually want a decimal answer. So we could go ahead and do that. There's a command in Maple that's called eval_f. It means force evaluate. Force evaluate. So we're going to use it. It looks like this, eval_f. Whatever you do is, how you use it is you put something inside of it and it'll turn that answer into a decimal answer. So in this case, if I write 10 over 3 in parentheses after using my eval_f, right? I got 10/3 inside of this eval f. Once I press enter, you'll see that it now gives me the decimal answer of this. So this may sometimes come up in class because, you may be looking for an answer, maybe an x value or y value, and you get a fraction answer. And you're like, well, I'm not sure if that's between 3 or 4, right? It's probably good to know exactly where we're at. So this is a good way to force evaluate and get your answer in a decimal form. All right, next I'll do some exponents. Let me give myself some space under. Let's say we were doing something like 2 to the 5th power. We just want to write 2, then shift 6. Shift 6 gives us the caret, which brings us to the sky. And then we'll put the number it is that we want to put the power to. So in this case, let's say we were doing 2 to the 5th. Write it just like this. Press enter, and we see that we get our result of 32. Next, we'll talk about some square roots. To do a square root, we can just write SQRT, and then the number that we want to take the square root of. So in this case, let's say we wanted to do square root of 4, we could write it like this. Once we press enter, we'll see that we get our result. In this case, square root of 2 is 2. I'd like to turn your attention to the expressions tab here. If in case it looks like this, you just have to click on it and it'll open it up. You may notice that a lot of the things I'm going over are actually right here in this expressions tab. So in case you forget how to make the plus symbol, the minus symbol, the multiplication symbol, you can always just come here and click on these. So let's say I wanted to do addition. I can click on this and then just fill out the numbers, right? I can write 5 here, erase this and put 5 here. And this works just the same. So in the case of square roots, sometimes you may forget that the square root is SQRT. You can always just click on this one right here, put a 4 inside, and it works just the same. So please feel free to use either the expressions on the expressions tab or running them out manually as you see fit, right? In case you forget, don't feel bad. You can always just use the stuff that's right here. And in that same regard, if we wanted to do a higher root, let's say we were doing a 3rd root or a 4th root, we use a different command. It's called surd. Looks like this. Let's say we were doing the 3rd root. Yeah, 3rd root of 8, something like this. We would write 8 and then comma 3. This tells it that it's taking a 3rd root. And I'll pick a different one number so you can actually see what it looks like. As we can see here, this is kind of what this looks like. It turned 8 into 2/3. I mean, 2 to the 3rd power, but if I do something like this, it looks a little better. So as you can see what it's doing, it creates a fraction for the exponent, which is the same as just putting a higher root. So in case you don't want to use surd, you're like, what's surd? Surd is a very common thing that we all forget. I forget it sometimes too. So I do like using this thing here on the left. It does the same thing. So if I was to write a 4 here, put a 2 on the inside, you see that I get my same response here that I get here. So please feel free to do it either way. Surd is the command that we use, and then this is here on the left side of the expressions. All right. Next, we're going to do some absolute values. Absolute values. So absolute value, we just write abs, and then the number we want to take the absolute value of. So let's say we're doing abs of -2. Looks like this. And then, of course, we can use the symbolic version here on the left. Click on it, and then put the number on the inside. All right. Next, we have E, and E being like 2.718 or Euler's number. To do that, we just want to make sure we don't use the regular E. So this E doesn't mean anything. If I press enter, you'll see that it just says E, right? But if I put like EXP1, you notice that this is a different looking E. So this normaler, less curvy looking e is actually the good e. So in any case that you want to go ahead and make an exponential function, do e of some sort, you're just going to want to write it with exp, and then inside the parentheses, whatever the exponent is. So, e to the first power is exp of 1. If you wanted to do e to the x, you write exp of x like this. You can also hit this e here on the left. So this e is the correct e. You'll notice that it's not a curvy looking e like this e. So it is the correct e. And you just have to go ahead and change the exponent after that. So in this case, if you wanted to do e to the first, you write e to the first like that, or e to the x like this. So just as a quick reminder, if you ever want to do e as an Euler's number, don't just type the letter e. Either write exp of x or click on the e here on the left, because the regular e isn't actually a number. It's just the letter e. All right, next we have ln. And ln is pretty nice and smooth. We just write ln, parentheses, and then whatever we want to take ln of inside. So let's say we're doing ln of 2. We get back ln of 2. And as I mentioned earlier, we have a bit of a little command we can use to approximate this, right? Approximate what this is. We'll use that. That's our eval_f command, right? Eval_f. We'll write ln of 2 inside of it. And we should see what this approximates to. And last general command that I'm going to go over is sine, cosine, and tangent. Well, I guess expressions, I'm going to go over sine, cosine, and tangent. Let's say we're doing like sine of pi over 2. The way we want to write that is sine, parentheses, and then we're going to use a capital P and a lowercase I over 2, just like this. I'll tell you now, if you use a lowercase p and a lowercase I, it will make this symbol. So you will not receive a numeric answer, you will receive a symbolic answer. And if you put pi like this actually is not pi. This means to multiply. So it's very important that you put a capital P and a lowercase I. That is the correct pi. In case you're looking for pi and forget how to make pi, you can get it here. It's in common symbols. So it's not in the expressions tab, it's in the common symbols. This pi, I do believe, is the lowercase pi, like that. I mean, you of course can still eval_f this and get the correct answer, like this. Yeah, actually, no, it doesn't. It doesn't want to turn that into a number. So yeah, as long as you make a lowercase pi, it's not going to want to turn that pi into a number. It's going to try to keep it as a symbol as much as it can. So very important that if we're going to use pi, we just want to make sure we use a capital P and a lowercase I to make sure that we get numeric answers. All right, I've pretty much gone over all the expressions. I'm gonna then now go over how to create functions in Maple. Anybody have any questions on the expressions or what we're doing so far?
No.
Sweet. All right, and reminder that this will all take a little bit of getting used to. I will post a recording. Ideally, you're copying some of this over, but if not, just afterwards, I would recommend copying some of this stuff over because it does help to do it, to commit it to memory to some extent. All right, and now next I'm just going to talk about how to make functions. So let's say we had a function called f of x, something like this, and we want to define it to be something. We want to let it be x squared plus 1. Let's say it's x squared plus 1. The way we're going to do that is by putting a colon and then an equal sign. When you put these symbols together, it makes this funny looking symbol, and this symbol means the word is. So right now this says f of x is. So again, we want to write f of x like this. And this f, of course, can be whatever name you want, right? You can name it f, g, h, any letter that you really want. You can also have stuff like H1 or Fred. You know, you can really name your function anything you like in Maple. It's pretty flexible with that. But you know, we're starting with F. And reminder that to make that symbol, you put a colon and then an equal sign. When they come together, they make this symbol, and this symbol means is. So right now this says f of x is, and then we want to tell it, you know, what f of x is. In this case, it's x squared plus 1. You may notice that the response is a little different. It's written in the old way. So this is written in the way that we used to write functions in this way. So back in the day, we used to write functions like this. So you used to have to make this symbol and then also make this symbol. They shorthanded this so that way it's a little faster, and it's honestly easier to remember, right? Like it's easier to remember that f of x, you can just write it like f of x. You don't have to write it like this. So I highly recommend using this method, but just note that it may give you this thing when you return it. So it may do this. It's still the same. So just know that this works just the same. Oh, sorry. All right, now I want to use this. Let's say I wanted to plug in 0 into this equation, right? I can now do that. I can write f of 0 like this. And then it'll go ahead and plug in 0 here. And we see that we get 0 squared plus 1. And 0 squared plus 1 is 1. Right, so now this is pretty convenient because I can plug in any number. This is now pretty similar to plugging this into something like Desmos or another calculator and then being able to use that function over and over again. So that's pretty much what we did here. We can go ahead and now we define this and we can start using it over and over again. Sometimes we're not asked to plug in a number for x, but instead we're asked to find a value, you know, for x. For example, sometimes they ask us to find zeros of our equation or the roots, right? If they ask you to find zeros or the roots of the equation, they're usually asking you to figure out when f of x is equal to 0, right? And you're looking for the x value. We can also do that with Maple, and we're going to use a command to do that. It's called solve. So if we use a solve command, we can give it any expression inside, and it'll solve that expression for us. Meaning that whatever we put in there should have an equal sign so that it knows what to solve for, you know, or a greater than or less than symbol. But generally, we'll be using equal signs. So in case you ever get a question that says, when is f of x equal to g of x? We could definitely use a solve command for that. They ask us, what are the zeros of your equation? We can use a solve command for this. And yeah, so we're going to use a solve command, and we're going to solve when f of x is equal to 0. So you can write it just like this. And before I press enter, should we get any solutions for this one? Is there any situation where x squared plus 1 is equal to 0?
Positive and negative, both.
You saying we should get solutions?
Oh, no. Yeah, it's not -1. Okay.
Yeah. If it was -1, we would get 2 solutions, as you mentioned. But in this case, this is elevated. And we're going to draw it in a second. I'm going to make a little plot of it. But just for now, you can, if you're not too sure, you can definitely just believe me that when I press enter here, we get solutions, but they're imaginary. So these are not real solutions because there is no situation in this case where f of x, you know, equals 0. Quick follow-up on solve. Let's say you want only numerical answers, or you want your answers to be changed into numerical values. You don't have to like eval your solve answer. So let's say your solve answer was something like pi or something like symbolic, like a fraction or something. You can use fsolve instead. So you can use the command fsolve and do the same exact thing. And what this will do is it'll only respond with real solutions, and they're going to be decimal form. So in this case, these 2 solutions are imaginary, right? So when I run this, you're going to see that nothing happens, which is good because there are no real solutions, nor solutions for it to turn into decimal form. So press enter, you'll see that nothing happens. You may go, that's a little weird. Nothing happened. That's actually good because there's literally no solution to this equation. So yeah, solving, very useful, very, very useful. We're going to use it a lot. All right, and now one last command before we swap over to the lab itself is going to be plot, the plot command. Plot also really, really useful. You will see that most questions that we do usually will ask, can you define this function and then plot it and then answer some sort of question about the image that you've drawn. And luckily, plotting in Maple is really, really fast. So you just have to literally write plot and then whatever it is you want to plot inside of it, close it, and you're good. So in other words, if I wanted to plot something, I really just have to run this first line to define it, and then the second line to plot it. Meaning that we can generally plot pretty quickly on Maple, right? We just have to define the function and then plot our function. It's pretty fast. We can add a lot of features to this plot to make it more specific to our liking. Let's say, for example, right now, the default for the X values is -10 to 10. So that will generally, that will always be the default. It'll use different values only if it doesn't exist in some of these values. So let's say we didn't exist here on the left side, it will only show us the right side and probably give us some more positive values. But by default, it uses -10 to 10. So if I wanted to change that, I could add a comma here and I could write X equals and then give it some values. So let's say I wanted to do -5 to 5, I would write -5 ... So you had your hand up?
Yeah, I just have a quick question. Can we copy that graph?
What do you mean? Like this?
Oh, yeah. Okay. I just wasn't sure if that was doable.
Yeah,
Okay.
you can copy it. We can actually add a lot of stuff to it too. I was going to mention this in a second, that a lot of the stuff you can add, you can also right click here and do. So you can change things to be a certain style. Let's say we want the line to be dotted line, a dash line, essentially different types of lines. We can change the colors of our lines. We can add an axis. Add a legend so that it actually shows us which curve is which. I'm not gonna go too into all of these little features because generally we don't use them too much. We mostly just use this part. So if we want to make sure we plot, we always want to make sure we write whatever it is that we're graphing, and then X equals the values that it is that we're interested in. So if I rerun this, you'll see that my X values changed, and it is no longer -10 to 10. It is now -5 to 5. I'm going to show you one thing that we use very rarely, but it is useful. Let's say we wanted to box this in a little bit more, right? Let's say I only cared about what was going on between, I don't know, right here, this little box, like 0 to 2, and then 0 to 5 on the y-axis. I could go ahead and get real specific and put this to be 0 to 2, and then 0 ... Oh, I gotta write y equals 0 ... 5. And you'll see that it actually creates a small box, pretty much makes a box around the area that I'm looking at. This we won't use frequently, but it is useful in case you ever get a problem that says something like, what happens when x equals 2? And you really want to like zoom in to when x equals 2. And let's say the graph is like kind of splitting you up and moving you up and down. And you're like, I can't see what's going on when x equals 2. This would be like a way to do it. I guess more specifically here, in the middle here, I have x equals 1. So this would be a good example of how we could see what's going on when x is 1. Right. So yeah, just a quick note. We don't use this very often, the y equals part, but in case you want to make a box, this will essentially constrain you to a box on the graph. So just note that that's what that's going to do. And it can be useful. It can be useful. But generally, most of our graphs are going to look like this. We're just going to write plot f of x, and we're going to press enter. Because if they don't ask us to put any specific x values, we don't have to. We just plot it just like this. All right. And actual last note on this plotting thing. Let's say we wanted to plot multiple things. We could do that by putting a bracket here and then writing the multiple things that we want to plot. So let's say I wanted to plot x, x squared, and my f of x, right? I can write x, comma, x squared, comma, f of x. Close this, and then I got to close it for the other one. Press enter, and you'll see that I get my 3 images right here. They're a little bit on top of each other, so I'm going to actually zoom this in a little bit so that we can see a little better. And now you can see our 3 lines a little better. If you're wondering, hey, which one is graph 1, which one is graph 2, and which one is graph 3, or like line 1, line 2, line 3, you can go ahead and right-click, go to Legend, and then hit Show Legend. This will show you curve 1, curve 2, and curve 3. And these correlate to this in this direction, right? Curve 1 is this one, curve 2 is this one, and curve 3 is this one. So it will always be written in this order. I think there is one question. I think the last question for lab 1 actually asks you to graph 2 functions on one. So this will come up. And we just want to make sure we write it just like this, right? We can write our multiple functions in here. Let's say I had defined g. I could have just written g of x here instead of having to write x squared. In this case, I didn't define g, so if I run this, it's not going to show me anything. But all right, I'm going to move over to the actual lab itself. But before I do so, anybody have any questions on the stuff that I went over here? Awesome. I'm going to save this document as our lab 1 sample, and I'm going to upload it by the end of the class to the same lab location. So where it says, I'll show you what I mean. I'll show you right now. All right. So I'm going to attach it right here to project 1. So you'll likely see a Maple assignment PDF, example for Maple assignment 1 PDF, and then there's going to be a third file here that's just going to say Maple 1 sample, and it's going to be a Maple file, so end in MW. And you'll be able to open it and pretty much look over all the commands that I ran today. If you want, you can copy any of them, rerun them, whatever it is you want to do with it. You can play with that sheet as much as you like, because it will be your own saved copy of it. And the next content that I'm going to be going over is exactly this one. So it's going to be this Maple assignment 1, as well as this example for Maple assignment. What you'll notice is that Maple assignment 1 and example for Maple assignment are pretty much the same. The only difference is that the example uses different example like problems. So like the equation that's being used is different, but the process that is being asked of you is the same. In other words, I'm going to do number 1, and you should expect to use the exact same commands for number 1 on your end. But you will receive a different result than I did because we're using 2 different equations. But the process essentially will be the same. All right, so I'm going to jump into that now. I'm going to go ahead and show you how I normally would work on a lab. What I'd like to do is kind of make this half my screen here. Let me make a new document. And then on the other half, I would put the lab itself. So this is the lab itself. And here we see that the lab says, given the functions, this function, we want to go ahead and find some stuff, right? And right before I get into that, let me zoom in up here. I'm going to write my name. I am Byron Radrigan. This is our lab 1.
Spending time with
I'm sorry? Did somebody ask a question? I think it might have been a mistake. All right. So yeah, here's our actual lab 1. I'm technically doing the example, so I'm going to write example here. So I don't want to trick anyone and they're like, you said you were doing lab 4. All right, so my problem for lab 1 is going to be the same. It says given the function, but mine function is going to be a little different. We're going to want to use maple to use a maple command to separate the denominator. We're going to find the zeros of the denominator. We're going to find the vertical asymptotes. And then lastly, we're going to confirm our answer by graphing the function. Right. Let me get my actual equation because my equation is different. Mine is up here. Yeah. So for mine, I got a different problem. It's x plus 1 divided by x squared minus 1. So you see that this one's a little different. So question 1. You can always write number 1. You don't have to write question 1. However you want to write this. I want to first define my h of x, right? Got my h of x. And they told me that my h of x is x plus 1 over x squared minus 1. So far all I've done is define it. I did have to put parentheses on the top so that way the division divides the entire thing. So just a quick note. You want to go ahead and put parentheses on the top if you want to make sure that you divide the whole thing, because if not, you'll get just like something like this, which is not exactly what you're looking for. Next, we're pretty much just asked to use a maple command to separate the denominator. I didn't go over this command, but it's a pretty basic one. It's called denom. So we just write denom, and then inside of it, what do we want to find the denominator of? So in this case, we want to find the denominator of h of x. So we write it just like this. We press enter, and we see that it returns to us just the denominator of h of x. So I'm going to go ahead and make some space going down. And next we're asked to go back. It says to find the zeros of the denominator. So next we want to find the zeros of the denominator. Again, this is our denominator right here, the denom of h of x. So we want to find zeros, kind of similarly to how we did it earlier with that other equation. We're going to use that solve command. I'm going to use that solve command. So we can write solve, parentheses, and then we want to solve when this, right? When this entire thing, so I just copied and pasted it over, equals 0. So just a reminder, copying and pasting in Maple is completely fine. Please use it so that you don't write the same thing over and over. We can go ahead and write that denominator of this thing is equal to 0. And, you know, there are ways to set this equal to something and then rewrite it like that. So I could have said that this is like, I don't know, some letter A, and then write A equals 0. But for now, I'm just going to try to get you all just kind of used to using this. So yeah, so we can write solve denom of the thing equals 0, and this will go ahead and give us our solutions. And so we see that right now we have two solutions, right? We have 1 and -1. Next, we're asked to find our vertical asymptotes. So next it says find vertical asymptotes. So for C. So if we know when the denominator is equal to 0, how can we figure out if they're vertical asymptotes or not? All right. So if it's discontinuity, in other words, these two right here, they're considered discontinuities, right? Because they're zeros in the denominator. If the discontinuity is the same, if the zero is the same in the denominator and the numerator, then we say that that is a removable discontinuity. In other words, it is not a vertical asymptote. So if our discontinuity is removable, it is not a vertical asymptote. So what I want to do is basically solve my numerator and figure out when my numerator is equal to 0. And if the solution is the same in the numerator and the denominator, that solution is not a vertical asymptote. Meaning that any remaining solutions, if any exist, will be vertical asymptotes. Anybody have any questions on that? No. All right, so I'm going to go ahead and solve my numerator then. So I can write solve numer my h of x equals 0. And I see that I get the solution of -1. So it does seem here that my -1 is both a solution in my numerator and my denominator. That means that it is a removable discontinuity. In other words, my vertical asymptote is only at x equals 1. So this one is a removable discontinuity. That means my vertical asymptote is only at x equals 1. So I can write vertical asymptotes at x equals 1. And this would be sufficient. Your professor wrote some extra information here. He wrote some extra info about, where we're defined, what is a removable discontinuity, all that good stuff. You can do that as well. But generally, the question does ask, where are your vertical asymptotes? And so you want to make sure that you just respond with the vertical asymptote is at, in this case, x equals 1. All right, and one last thing is we want to plot this. So I can write D. And plotting it is just as simple as writing plot my h of x. I notice here he writes x equals -5 to 5 and y equals -10 to 10. That's not specified in the lab, right? It's not written here. So don't feel like that's a requirement. If they ever tell you to, if they tell you to graph something and they don't confirm where you should be looking at, you can just leave it as default. But if it does say what is happening when x equals 2, you should probably zoom in to x equals 2. So we'll have to use a little bit of context clues for that kind of situation. But if it doesn't tell you what to put in, don't feel like you have to know to put this in, because we wouldn't put this in. But we do want to use this. So this discount equals true and discount equals show removable. I didn't speak about too much. As I mentioned, there's a lot of features to these plots that could be useful. For this specific lab, we're going to use this discount equals show removable. So you don't need the true one, because show removable does what true does and more. So in other words, discount equals true. Discount equals show removable does everything that discount equals true does and more. So we don't have to use both. So in other words, I can just write this and then write discount equals show removable. And I'll get my graph. And we'll see that my graph has a circle, an open circle on it. So this is my removable discontinuity. And then here is my vertical asymptote. So that's about it for number one. Number one on your end should actually be the exact same process. So you should run this command with, of course, a different equation here. Solve your denominator. Well, get the denominator, solve it, solve the numerator, then note if the solutions are the same. If they are, then that one's not a vertical asymptote. Anything that's excess in the denominator is a vertical asymptote. All right. And then lastly, you just want to plot it. So these are the commands you want to use. It should be exact same commands for your side. Any questions before I move on to number two? Awesome. All right, so for number two, I'm going to go ahead and go to the question itself so you guys can see what it is. So question 2 says, given these functions, we have a, b, this should be a c probably, but a, b, c, d, a, b, d, e. We just want to solve these three things. So we want to plot each of these on a separate XY coordinate system, and then we want to answer these three questions. The way you want to do this is essentially you'll do A, answer the three questions, then do B, answer the 3 questions, etc. And I know this probably seems like a lot because you gotta answer 3 questions, but I will say that the only work that goes into this is actually plotting it. Besides that, we just have to type some stuff out. So it's actually not as bad as it may look to seem. So yeah, so I'll just get right into it. You have question 2 here. And my question A is going to be slightly different than your question A, but they're both still lines. So the answers are going to be relatively similar, right? 3x plus 7 is a line, and my equation is going to be 2x plus 1, which is also a line, right? And what I'm asked to do is plot this. So I'm going to write f of x is 2x plus 1. And now all I need to do is plot it, right? So I can write plot my f of x. Here he wrote x equals -5 to 5, but in reality, because they didn't tell us a specific domain, we can just put it as default, and this is perfectly fine as well. All right, now with this, what is the domain of this function? By using the picture.
Infinity.
Yeah, negative infinity to positive infinity. And I can write negative infinity like this. I can also hit the symbols that are here. So in common symbols, there is an infinity symbol. Feel free to use it if you would like. Next, our range. What will be our range for this linear function?
Infinity.
Yeah, it'll also be negative infinity to infinity. And that's because this is a line, right? There is nowhere I can plug a number in and get a discontinuity. And, any y value I want to hit, I'm going to eventually hit by either going either negative enough or positive enough. So, yeah. Next we'll do B. B says type of function, right? What type of function is this? Let me see, because I think the other one uses more words. Yeah, this one says identify the type of function for each of the functions above, i.e. rational, exponential, etc. So this one is what type of function? And I think I mentioned it earlier.
Linear.
It's linear, yeah, this one's a line. So we're just gonna say this is a linear function. Thank you for responding. Appreciate it. And then in general, the domain for a linear function is always what? In general. Oh, let me go back to the question because I feel like we didn't read it. So the question for part C says, in general, what can you say about the domain for each type of function? So in other words, what can we say about the domain for all lines? For all lines. So in general, the domain for all lines will be, and what will it be? It'll be negative infinity to infinity, right? Pretty much the same thing we got here. So the domain of any line will always be negative infinity to infinity. And ideally, by going through this process, you'll see that, there's some trends like that. Certain functions always have domains that are like this, maybe ranges that are restricted in a certain way, or maybe their domain is always restricted in the same way as well. For example, like a fraction, we know that the problem with a fraction will be that the denominator can't be 0, right? And so that's an example of a rational function. And we'll have to describe, what the domain of that would look like. Any questions here for number 2? All right. That might be it from my end. I think I do have one last thing. There's some stuff here towards the bottom about how to write sine in Maple, how to write e to the x. We did go over these things in the sample. So this stuff is here in the example that your professor put up, but it's also